Hello students, I'm gonna discuss about the second unit in the computer organization and architecture. So the title of this unit is data path and control. So students, in the second video I'm gonna discuss about arithmetic logic unit and register file connection. As in the previous video we already discussed about how the fetching is happened and how the connections are transferred from between these particular five stages of process. So here in the in this entire process, how this particular register file is connected with the arithmetic logic unit and the register file. So let us see here in this diagram on the right side of your presentation. So where the register file, right? So this particular register file is having, right? So six kind of connections. So the first two will be this first two will be addresses A and B, and another one there is an address C. So you have three A, B, C address, and the output of this particular register file is A, B, okay, and the input, another input is C. So what exactly this register file will do for successful operation, that means transfer of information, that is the particular data to the ALU for further process. Let us see the source register A connected to in A of an ALU. So I told you, right? So the two outputs of this particular register file A and B, which is directly connected to the inputs of the arithmetic logic unit. So the A is directly connected to in A of arithmetic logic unit, whereas the B is connected, right, to in B of arithmetic logic unit via MUXB. What is MUXB? MUX is the multiplexer B. So here we say the multiplexer MUX B is connected to the in B of the arithmetic logic unit and the immediate value field in the IR. So here the mux B, usually the multiplexer is always many to one, we used to say it, right? You might be studied in your previous courses which you have in the engineering courses in the first year you might be studied. So here in the multiplexer you have two inputs and one output. So what is the input? One is directly connected to the output of the register file, right? That is to the through the B, where it says that 0, the value 0, and another one is immediate value, right? Immediate value, right, that is mentioned as 1. So based on these two conditions the mux will be sending an output. So here you can see that immediate value in the field of IR. So the mux will select the input depends on the instructions being executed. So what is the instruction? Right off, like in the program. So we have that five stages. The previous video that we just said, what are the five stages? The first is fetching. Second one is decoding. Third one is execution. Fourth one is the memory access and read write. So here this particular mux B, what it will do was, so is it if it is an immediate value, then it will go in this operation. For example, in your instruction, if you are fetching the data immediately from any of the IO devices, then it will go for an immediate value. Or if you are storing the data in any of the register, then it will fetch, right, the value from the register file, that is worth 0 and 1. So here you can see mux selects in B for operations that require only register operands. So register operands means inside the register you have different types of register, general purpose register A, B, C, D, like that goes on different registers. If that data are fetched from the register, register operands, then automatically it will select 0. So if it is right, if the multiplexer selects immediate value that are required, an immediate operand. So immediate operands, any value outside of this memory directly fetching from the external source of the memory. So like that way, so this particular ALU and register files are connected based on the instruction, right? So based on the instruction, for example, let us take same example as we see in the previous slide, previous video. So where add A comma B, okay? So this A and B is a register which is in the register file, okay? So if you put add A comma B, what happen is they are gonna add, right, register, right, A and B and put into register A, as I said before. So now A will be, the data from the A will be transferred directly to the ALU, and B will be, right, going from through the MUX. So here we are using the register, so it is connected directly. Now the 0 will be set. From the 0 the value will go to the in B. So what happens? So now we have the value of register A and value of register B. The instructions that we are given is add A plus B. So now B will be added, the content of that register B will be added to the content of the register A and put into the out. So the out is directly connected to where? To the C. So as I input to the register, so where through the C to this particular register A, which is inside the register file, the data will be stored into it. The answer will be stored in the register A. So this is how an ALU is directly connected to an register file. So let us go to the next slide. So where you can see an example of load R5, right, comma X of R7. So usually load R5 X of R7 is what? So we already seen again in the previous video where this load operation. So what we will do is we will try to understand how this particular load operation works with the connections here. Okay, so as we already studied in the previous slide, this particular part, you can see that this particular part we already studied. That means this is a register file and you have register A, RA, RB is directly connected to in A of ALU, and B is connected directly now indirectly to in B through the MUX B, right? We know what is immediate value and what is 0, what is 1, and this particular register file. So this address A, address B and address C is, so this instruction register which address particularly this our data is there. So let us see what happens in the stage 1. There is a 5 stages, we already know it. What is the first stage? First stage is what? Instruction fetch state. Okay, so this is what the 5 stages of organization. Always first stage will be instruction fetch, second stage will be, right, from the source register we are just trying to fetch the data, and after that arithmetic logic unit operation, access the memory and put the data into the memory. So here instruction stage 1, right, fetching stage 1 to 2, some decoding process will be happening, fine, and after that you will be trying to execute, and after that you will be accessing the memory, and after that putting the data into the memory. So these are all the 5 stages that we have seen already. So let me jump into the this particular sample examples. So first what happen is program counter is there. So the program counter will try to access the memory address which is located into the register, and after that in the particular register there will be an IR. What is IR? Instruction register. So from the instruction register, the memory data will be, right, moved to this particular instruction register. In this instruction register, what it is there? Load. Okay, load will be there. So once the instruction is fetched, and then what is the role of this program counter? Program counter will increment to 4 based on the size of this particular instruction. And then this first stage is completed. So first stage is what? It is a fetching stage. Okay. In the fetching, now we have fetched the particular instruction from the memory and put into the instruction register and then incremented the program counter. What will be the second stage? As per that 5 stages, the second stage always will be the decoding of the instruction. Now, what is the decoding process? So, what is load function? So, that is the decoding process. And after that, after decoding it, what I am doing is I am trying to move this particular R7 to RA register A. And after moving it, what I am doing is I am trying to move this to RA means what? So here you can see I am in the diagram, you can see I am moving from the register file to RA. And after doing this process, what happens is I am this particular ALU will try to do this execution, and after execution you will get an out. So that is what always we just see in the stage 3. Stage 3 will be execution stage, so where arithmetic logic unit will try to execute the data which is moved from RA and this RB. Okay, so after execution the data will be out, the answer will be out. So to what? RZ. Okay, so to that RZ, and after plus immediate value of X. Okay, so X is what? You have that immediate value in the X. I am adding it, and then I will get the answer for this one. And the fourth stage will be, so RZ. So this particular RZ, so based on the instruction what we have given in our program, so either we can push this particular results to the memory address, or what we can do is, so we can send it to the register files back. So here you have the three multiplexers, 3 to 1 multiplexer. So where 0 1 2, if it is set 0, directly it push to RY. If it is set 1, then it will be getting the memory data, and if it is 2 means it goes to the return to the address. So now let us take an example of 0 where it moves to RY. So that is what? From RZ to memory address, and after that read the memory and then move to the RY. So now we are just moving to the RY as per the instruction here. So it is in the register R5. So now RY data from the RY, it will be moved to where? To the register file where you have R5 into it. So the answer will be stored in the R5. So this entire process I have already given as simulation, and we are also practiced using the simulator. Okay, so these are all the sequence of steps that I have just explained to you, So first thing is program counter with a memory address, read the memory, and then move to instruction register, increment the program counter. After incrementing, decode it, and after decoding it, do the arithmetic operation. After the arithmetic operation, move to the memory based on the instruction, either if it is an external, then move it, or then try to move it as per here. We are moving our answers to R5. So this is a very simple way of understanding how an register file, ALU, and the memory are correlated to execute the given instruction with respect to these 5 stages.